Hey everyone, thanks for tuning into this session. Just before we get started, just a thanks to the guys for organising Actually Back to School. It's a great initiative. It gets lots of different sessions and lots of different content out there on many different areas, and I certainly learn a lot from it every year, and hopefully you are too. Okay, so let's get going. This is going to be a bit of a lightning session in some ways. I wanted to use Actually Back to School as a kind of kick off for a little project around just creating quicker, shorter, quicker content, delivering kind of key information as quickly as possible. So this is what this is really, and I'm going to be hopefully doing more of these in the future. So in this session, we're going to be doing it a bit like a notes from the field around building .NET microservices, and there's not a lot of in-depth content really to this. So we're just going to look at 4 different areas, and those 4 different areas are really going to be what we talk about, and hopefully we're going to make this no longer than 10-15 minutes, just so it's quicker to digest and you can come back and watch it again really quickly and easily within a quick break at work or lunchtime or while you're traveling. It's something that you can easily digest. So we're going to look, and I guess first of all, actually, before I start, I should say that these are kind of the common things that I talk about with customers and that I've seen from talking to people around building microservices using .NET. So it's certainly not an exhaustive list, but there's definitely the top things that we talk about on here. So I thought this would be a good thing to start with, and we will take it from there and see how it goes. So we're going to talk about choosing between .NET and the .NET framework. It's probably going to be an area that we use most of the time on, to be honest. We're going to talk quickly about container design principles as well, some security considerations, and also the build and deployment of containers as well. So let's get cracking. So first of all, I guess just some general guidance. So if you were to use .NET 7, for instance, or soon to be .NET 8, with either Linux or Windows containers for your containerized application, if you have any cross-platform needs, for example, you want to use both Linux and Windows containers, your architecture is based on microservices, or you need to start using containers fast and want a small footprint per container to achieve better density or more containers by hardware unit in order to lower your cost, for example, then going with regular .NET is a great way to go. An extra benefit, obviously, as well to using .NET is that you can run side-by-side .NET versions for applications within the same machine. That's obviously more benefit for servers or VMs that don't use containers, because containers isolate the versions of .NET that the application needs, providing they're compatible with the underlying OS, of course. But there are still some use cases where you'd want to use the full .NET framework. So if you're building or migrating a legacy application into microservices, and you can't start from scratch, your application may currently already use the .NET framework and may have some strong dependencies on either Windows itself or Windows APIs that are not supported in .NET 7, or you may even use third-party libraries or packages that are not available in .NET 7. So there's a strong use case there still for using .NET Framework, but generally speaking, if we're building microservices, we're starting from scratch, and it's a greenfield project. And containers are more commonly used in conjunction with that microservice architecture when it's a greenfield project. So you can use the .NET Framework on Windows containers, but the modularity and lightweight nature of .NET 7 makes it perfect for containers and perfect for a microservice architecture. So when you create and build your container, its image is far, far smaller with .NET 7 than it would be with the .NET framework. Okay, next, just on to some, excuse me, some design principles. Now, these are not exhaustive, and some of these obviously occur. Sorry, there's some considerations that you would need to make for architecting the application from the outset, and that's probably a separate video because there are a lot of different design principles. And I will put a link to what they are in some really good Microsoft documentation in the video that's down below. You can go look at them and look at them in more details. This is just more generally around the concept of container design principles. So, in the container model, the container image instance represents generally a single process. So by defining a container image as a process boundary, you can then create primitives which are effectively used to scale or batch the process. When you go design a container image, you'll define what's called an entry point definition in the Docker file. That definition defines a process whose lifetime controls the lifetime of the container. So for example, it might be a long-running process like a web service, an API, but it could also be a short-lived process as well, like a batch. Something that you might previously have ran in something like Azure Web Jobs or something like that. When the process completes, the container lifecycle effectively ends. If the process fails, for instance, the container fails and then the orchestrator takes over, i.e. Azure Kubernetes service, for example. If the orchestrator was configured to keep 5 instances running and one fails, the orchestrator will then create another container instance to replace the failed process. In a batch, for instance, though, the process is started with parameters. When the process completes, the work is done. You might also find a scenario where you want multiple processes running in a single container. For that scenario, since there can be only one entry point per container, you can use a script within the container that launches as many programs as needed. For example, you can use a program called Supervisor or any other similar tool to take care of launching multiple processes inside a container. However, even though you can find architectures that hold multiple processes per container, that approach isn't very common and does sort of break the microservice model. Okay, so next I want to move on to security considerations. Now, security is a big topic. Obviously, it's one that we could probably fill many different sessions with just talking about security, but I just want to touch on really the common ones here, which are authentication and authorization. So there are so many aspects about security, like we say, that we could expand that, but let's just focus in on these main ones really. So from a microservice perspective and from an API perspective, which is generally what we would use microservices for, we would publish those, and the service would be limited to certain trusted users or certain trusted clients. The first step in that is making API level trust decisions is authentication. And authentication is obviously the process of being able to reliably verify a user's identity, not to be confused with authorization. So generally we would use a service in the Microsoft world anyway, like Azure ID, previously Azure AD, to create app registrations, and we would have tokens then issued, and we would authorize access or authenticate access rather to those APIs. And then authorization would define what that person is allowed to do, so what calls they're allowed to make. You can use .NET Core Identity. You can obviously also use external providers, such as Google, Facebook, Twitter, or a Microsoft account in there as well. Those are all supported out of the box. You can use bearer tokens using OAuth 2 and OpenID Connect. And there's some really good documentation which I'll post the links to for you to go read in more detail. But really, this is something that you want to be doing from the start. You don't want to go retrofit security, especially authentication and authorization, in after the fact, because that can cause problems if you forget something. So a good tip for me is when you're creating a template of what your API microservice looks like, and I would always create a template, make sure that you add in any common security considerations, like making sure the service is tied up to the correct Ensure ID directory. Make sure that you have the right configuration in there and the right scopes that you want and what claims you need to use, all of those sorts of things. And then whenever you create a new API from that template, it is basically using the things that you've defined once, and that can then be updated as through the life of the application. But don't add it in. Make sure you use a template. Makes it nice and repeatable for one, and secondly, it means that you don't forget anything after the fact. Some other considerations that I would really advise strongly, it may seem simple, but they often get missed, is using a service like Key Vault to store secrets. Key Vault's a great service. It's very cheap to run. You can store lots of different types of secrets in there, from certificates all the way to key value pairs. Any common configuration, I would store that in Azure app configuration. Reason why is obviously anything that you define as an environment variable is effectively open. It's not encrypted. It's a plain text key value pair. So make sure that any common configuration you store in Azure app config. Excuse me. And when you store it in Azure app config, you obviously only have to update it once as well, and it will affect everything that calls that key in the future. So there's a much better way of being able to define what they are, and makes it much easier for you to manage from an overhead perspective. Also, probably teaching a lot of people to suck eggs, and I apologise, but it does always need to be mentioned, never hard code any secrets into your code. Which does bring us on nicely to building and deploying. Okay, so building and deploying, again, taking the same principles we talked about. It's obviously a different tool set. It could be GitHub, it could be Azure DevOps. The principles remain the same. Make use of dry templates wherever possible. So what that means is that, for instance, in Azure DevOps, you may define a couple of pipelines that are common, that are used to build your code and accept a number of parameters, and deploy your code or deploy your container image and have, again, another set of parameters. You can then call them from one template, from one pipeline rather, and call those two templates so that you're not recreating the wheel every single time. It means that if you need to update how your build works or how your deployment works, you're only doing that once. You're just calling them in separately on a per API basis. It's a much better way to build your pipelines. Again, make sure testing and security vulnerability scanning is done in your pipelines as well. We talked about secret scanning. That's something else that should be done there. So with GitHub Advanced Security, we can scan for secrets and so on and so forth. Another thing I see all too common, sadly, is in pipelines, lots of people will check continue on error or suppress errors. Excuse me. That's obviously something that we never want to be doing. If there's an error for a reason. We want that error to be brought to our attention and addressed so that we can fix it in the future. And maybe slightly controversial, but certainly, again, from experience, Helm's a great tool if you're publishing your containers or creating Helm charts for things externally. If you're only ever using your containers internally, Create a deployment manifest for AKS, for instance, using YAML that has template parameters in there, and fill that with template parameters. There's no point in creating Helm charts, in my opinion, for things that are only going to be used internally. You are as well creating a template that will go and deploy your container image to AKS without having the extra additional overhead of Helm on the top. By all means, use existing Helm charts for any common services you want to deploy and manage on your container cluster. But for your own services, unless you're offering them externally, just make it easy for yourselves and don't publish that externally. Okay, so aside from the cough that I have at the minute, which I apologise for the coughing, that kind of wraps up this video. So hopefully you've got some good tips and tricks there to help you along with your container building in your microservice deployments. And until the next video, thanks very much.